Hi there, let's talk about the enthalpy change in A-level chemistry. In part A, it says that in a petrol engine, alkane undergo combustion. Heptane is one of the alkane that we got. Write a chemical equation for the complete combustion of heptane. Bear in mind, this is about heptane, which have a chemical formula of C7H16. Hept represent 7 carbon. Complete combustion means it is being burned in oxygen, and it's enough oxygen. So let's start with the equation. C7H16 react with oxygen. If it's complete combustion, we are going to form carbon dioxide and water. And this is not the end of this question, because we still need to balance it out. We got 7 carbon on the left-hand side, which means I need 7 carbon on the right-hand side. We got 16 hydrogen on the left-hand side. I need it to be the same number of hydrogen, so I need 8 portion of water. And finally, we need to double check the value of oxygen on the right-hand side. We got 14 oxygen in carbon dioxide. We got 8 oxygen in this much of water. So in total, I got 22 oxygen. And on the left-hand side, I need to make sure that it's 22 oxygen, which is why I put 11 in front of the O2. And I think that's it for part 1. Let's move on to part 2. It says that in a petrol engine, polluting gases, carbon monoxide and nitrogen oxide are formed. These are mostly removed before being emitted from the exhaust. The equation for the removal of carbon monoxide and nitrogen oxide is shown below, and we can see this equation right there. It's balanced it out for us. Everything is in the gas form. They even write out the enthalpy change, which is minus 746 kilojoules per mole. And we need to remind ourselves, when you got a negative value for the enthalpy change, you should know that this is an exothermic reaction. And then it says, could you complete the enthalpy profile diagram? On the diagram, we need to label the enthalpy change of the reaction, which is the negative value that we have talked about. We have to include the formula of the reactant and the product, and we also need to label the activation energy, which is always from the reactant to the peak. Okay, in that case, let's start from beginning. Because this is an exothermic reaction, I'm going to put the reactant here on the top. I'll put the product at the bottom. And I'll just label it out right away that we got delta H minus 746 kilojoules per mole. For the reactant, according to the question, I got 2 portion of CO, gas. I got 2 portion of NO, also in gas form. For the product, the question told me that I got 2 portion of CO2, gas, and a portion of nitrogen, gas. And I need to draw out the reaction pathway, which is going to look like that. And I also need to draw out the activation energy, which is from the enthalpy level of the reactant to the peak, EA. And let's double check. Did we include everything that they asked us to? Delta H? Yes. EA? Reactants and products? Yep, everything is there. And then let's move on to the next question. In part 3, it says carbon monoxide and nitrogen oxides are removed by use of catalyst. Explain the role of the catalyst. Refer to your enthalpy profile diagram in the previous figure in the answer that we have written. Well, in this case, it seems like that we need to focus on the term catalyst. We also need to explain it, also need to combine it with the enthalpy change diagram that we have. You guys might remember that back then, we labeled out the activation energy, EA, which is the minimum amount of energy needed for the reaction to proceed. And in this case, because of the use of the catalyst, they provide this alternative pathway, which have a lower activation energy. And this is exactly why we are using catalyst. So for the answer, I'm going to write the catalyst can provide an alternative pathway with a lower activation energy so that the reaction rate will increase, so that the reaction will proceed faster. And then let's move on. For part B, it says, iron oxides react with carbon monoxide as shown. They write out the equation, they balance it out, they tell us the enthalpy change, which is minus 25 kilojoules per mole. And then they give us a table. It says standard enthalpy change of formation, Based on the symbol, we got the standard condition, and this is the formation of each of the substance. For part 1 at the bottom, it says, state the condition of the reaction and pressure for standard enthalpy change. This is purely based on memory. The standard condition temperature is 298 Kelvin. Watch out for the unit. The standard condition pressure is 100 kilopascal. Also watch out for the unit. And then let's move on to the very last question. Calculate the standard enthalpy change of formation for CO2. Well, even though the question didn't say it right away, but we need an enthalpy cycle in order to figure it out. And in order to have a cycle, I'm going to write out the equation again, and I'll construct the cycle accordingly. Okay, don't worry too much about this equation. I basically just copy-paste the top equation right here, and then let's write out all the constituent elements from all of the substance that we have in the reaction. We need Fe, we need O2, and then we need carbon, and that's it. We are going to try to form the Fe2O3, the carbon monoxide, the Fe, the carbon dioxide. And now is the time for us to label out the value for each of the arrow. For Fe2O3, the question told us is minus 824. For carbon monoxide, the question told us is minus 111, but I need to time it by 3 because I got 3 portion of carbon monoxide. For Fe in the product, we don't really have any value right there because it is the element itself. For 3 portion of CO2, that is the thing that we are interested in. We don't know what is the standard enthalpy change of the formation of CO2, so maybe I can just write out the algebraic expression. 3 portion of X, but we don't know what is X. And then for the enthalpy change of the reaction, the question told us is minus 25. Okay, and now that we got everything, it's time for us to write it out in pathway 1, pathway 2, from the same starting point to the same ending point. I'll show you guys how to do that in detail. Minus 824 minus 111 times 3 minus 25, that is the root 1, equal to 3x, that is the root 2. If we put it in a calculator, we'll get minus 1182 equal to 3x, x equal to minus 394 kilojoules per mole. And that is the final answer for the question. Alright, that's pretty much it for this enthalpy cycle. Please like and subscribe. I'll see you guys next time. Bye bye.